All right, so I just wanted to really briefly, for those of you who are interested, but don't want to just read it through the book, I do want to just explain to you exactly how the Riemann sums and the cylindrical shells end up working. So this is not really mandatory, but I think it's maybe a good idea if, either watch this or read about it in the book. So how do we see that the volume of the shell is approximated by 2 pi r h of r dr as the approximation for the shell? Well, here's the reason for it, okay? If I suppose that I have got some shell here, and it has an outer radius and an inner radius. Okay, so we have an outer radius and an inner radius. And then what we can do is we can say that the volume of the shell is going to be equal to pi times, let me make sure that I'm getting this correct. It's going to be r outer squared minus r inner squared. And then we also have to multiply this by the height as a function of r. But what happens when we end up doing this is we can write this as, and this is where this is what is a little bit tricky about this. We can factor this. Now, I'm going to call this RO and RI, so I don't have to keep writing this entire inner and outer here. So this is going to become pi times RO plus RI times RO minus RI, like so. And then we are still multiplying by the height as a function of the radius. And at this point, what we can say is this is equal to, and I'm going to write this in kind of a wonky sort of way. I'm going to write this as 2 pi times RO plus RI divided by 2, because of course I want to cancel out this 2 that I have here, times the height as a function of the radius times delta r, because notice that the outer radius minus the inner radius, this is just the change in r. However, what is this here? Well, in the limit, this is just the average of these two radii, and so this quantity here is just going to approach r as we take the limit as the outer and inner radius go to the same thing. So in the limit as delta r is going to 0, this quantity just approaches r, and so we end up with 2 pi times r h of r dr in the limit. So that is where this cylindrical shell thing comes from. Again, I didn't want to take time during the first lecture to kind of go into this sort of annoying arithmetic thing, but that's really what is going on here with finding the cylindrical shell formula. So hopefully that was interesting to you if you did not happen to want to take the time to read this in the book. Again, it's not like it's super long or anything, but it's just kind of a technical, annoying, fiddly thing. And as you can see, I had to keep making sure, like, oh wait, what am I supposed to do here? Because 2's appear out of nowhere, and we're figuring out all this kind of thing. Now, it's not really that they appear out of nowhere, though. It's just I have to remember where they're coming from, right? Because where it's coming from is I want to turn this quantity into the average of the outer and the inner radii. And when I do that, then in the limit, that's going to approach whatever radius we just happen to have. And that is where this 2 comes from, but that means that I need a 2 in the numerator, so to speak, to compensate. So yeah, it's a tricky little thing. It's not anything particularly difficult, but it's also not something that's particularly straightforward either in some ways. So anyway, there we go.